resultant vector by resolution method. Now I put my first concept for today. When you are dealing with two or more vectors which are acting in one position, one point, the final output vector is called the resultant vector. We had already written this concept before, that when two or more vectors are acting on an object, the final output vector is called the resultant vector. We made some examples on that. Now we are putting the steps method. The first step, resolve all vectors which are possibly inclined into components. Step 2, separately find the algebraic sum of x and y. And we have a very interesting formula. X is equal to right minus left and up minus down. Step number 3, R is equal to under root x square plus y square.
Sir, isn't the x and y axis?
No. It's not necessary in A level. X and Y components are formal, but for the time being, you can say fine, they are on the horizontal axis and vertical axis. So you have to copy these steps.
Done, sir.
R is equal to resultant vector tan theta is equal to y upon x. And when you make theta the subject, tan inverse, which is a mathematical concept, theta is equal to direction of resultant. In this chapter, vector has two things always, magnitude and direction. So magnitude is coming from this formula. R is equal to under root x square plus y square. This formula will give you the magnitude.
Okay, sir.
While the other formula R is equal to resultant vector and theta is showing direction, and you have done maths in O level. So you should remember that there is a problem with trigonometry if you put negative values, quadrant changes. So in this formula, always insert positive values of x and y. You have to now copy this screen.
Sure. Sir, in step 2, where it says separately find the algebra sum of x and y.
I will explain all of them because I have to. We are following a notes pattern, no? So sure. We have to explain all of them. And I think you are not taking maths in A level, right?
Yes.
Good. So I remember that. Now don't worry. First copy this.
Done, sir.
According to the sign of X and Y, locate the quadrant. There are 4 quadrants in maths, and you can see the quadrants plus X plus Y. And this is something necessary for you because you're not doing A-level maths plus you're not doing you have not done add maths in O-level. So this is something to remember, that how angle changes in quadrants. So you have to copy this screen.
Okay, sir. So what do the angles in like red written beneath
Angles in
minus?
red, I will explain it. This is something which is our O-level maths, but let's quickly recall from the title we are starting today, resultant vector by resolution method. Now, the step 1 is resolve all vectors into their components. This is the first step. Separately find the algebraic sum. Actually, the word is algebraic sum of X and Y components. Step 3, find the magnitude using this formula. And R stands for resultant vector. Then tan theta is a function actually. Tan theta is actually a function of trigonometry, and you can inverse the function to get theta. Always insert positive values of X and Y. Now, this table is not actually very difficult. The way actually I am here, I'm showing it here. It looks to be a very something high quality table. Actually, it is something from O-level maths, and it represents the idea that in different quadrants, how values change. Now, I want you to see this diagram. This is our x-axis. This is our y-axis. This is positive. This is positive. This is negative. This is negative. Am I right?
Yes, sir.
Okay. We label this as, this is only a formality to label it. It is labeled as first, second, third, and fourth, and we move it like this. So, I'm giving you a point 2, 3, where it will go.
I.
It's 1, 2, 3, 4 now. So
Yeah,
2, 3 will be in the first quadrant. Acha, 2 comma -3.
Quadrant number 3.
Quadrant number 3. Are you sure? 2 comma -3. X is positive.
Then 4.
Yes. -1 -5.
3. Quadrant 3.
And -3 and 1.
Quadrant number 2.
How you selected them? Answers are right, but how you selected them? X and Y plus minus changes. X and Y changes their plus and minus positions.
Yeah.
So in the first quadrant, X is plus, Y is also plus. In the second quadrant, X is minus and Y is plus. In the third quadrant, X is minus and Y is also minus. In the fourth quadrant, X is plus and Y is minus.
Okay,
Now,
sir.
do you understand this pattern now? This is our O-level pattern, nothing new, only a formality to understand, which is a language of quadrant.
Okay, sir.
Okay, now move to that angle concept. This is a knowledge of the quadrant, and now look at, these are the 4 quadrants. Okay, and what you have to learn, which I've given, this is called theta, which is called the basic angle. If you
Yeah.
want to come in the second quadrant, it is 180 minus theta. If you want to come in this quadrant, it is 180 plus theta. And if you want to come in the fourth quadrant, it is 360 minus theta. It is actually a concept of switching the angle. It is a concept of switching the angle. Now, for example, theta is equal to 30 degree.
Yeah.
It is in the first quadrant. Then if you want to bring this angle here, it will be 180 minus 30, which means 150. If you want to bring this angle in the third quadrant, it will be 180 plus 30, 210. If you want to enter this angle in the fourth quadrant, so this is actually the idea. This is the idea of changing the quadrant and the angle will change. Now, actually, this is a very fundamental O-level concept. I want to show you that how this is an O-level concept. Only a presentation feature is there, that if I draw a straight line,
The
and
time graph.
but if I put 30 here, what would be the angle here?
150.
This is a supplementary concept. Similarly, if I extend the line down and I ask you that if you want to mark an angle here, you will say that this angle is also 30. This angle is 150. Now, if you want to see this angle, and if you walk from here till here, it will be how much? It will be 210. Actually, this is an O-level concept which helps us to locate the quadrant first and then locate the angle. I repeat my concept again for understanding. Look again. If a vector is here, okay, if a vector is here and you put calculator tells you 30 degree. It means 30 degrees here, but actually it can't be 30. It has to be here. So when it is here, it will become 150. This is a manual transmission method to understand how we can change the position of an angle. For the people who have done O-level ad maths or they are taking A-level maths, this is a routine thing. But this is where every non-ad math student should be clear that actually there are two concepts, which one concept is here on the screen right now, and second concept is here. This is called quadrant search and this is called angle search. Now you have to copy this example screen.
Okay. Done, sir.
Okay, thank you, Ariba. Ariba, you missed the last class. I have shared a recording with you. If you can watch it, and also you have missed some initial part of this class. And as there are just like a way of recording, so that if you miss the last and the some part of this class, you can watch it back and you can make it connected, because if you miss something in the next time, it would be a problem to understand. Only inclined vectors are resolved. Horizontal and vertical vectors are not resolved. It means anything which is inclined has to be resolved. This is an important concept. You have to copy this screen. I'm just coming in 2 minutes. Actually, it's Maghrib time here. So I'm just coming in 2 minutes. You have to copy this screen.
Okay, sir.
this is the first example, and you have to copy this screen.
Okay, sir. No, sir.
So, Rima, have you copied it?
Yes, sir.
This symbol is sigma. This symbol is sigma, and sigma is used as a symbol in this chapter for resultant vector. Now, remember, we resolve only the inclined vector. We resolve only the inclined vector. Okay.
Yeah,
Now, which vector is inclined in this diagram?
the 10 Newton one.
Only the 10 Newton vector is inclined.
Yeah.
Good. See the first step. I have resolved the vector.
So the first step is to resolve the vector.
Yes, this is a step number 1 to resolve the vectors which are inclined. This is the first step. You can update the same diagram.
Done, sir.
Now, this is step number 2. Right minus left. Now, what is step number 2? We had written it in our list. Step number 2.
Separately find the algebra sum of x and y components.
And the main formula was right minus left. And this is our right.
Yeah.
And this is our left. This is our up vector and this is our down vector. Okay, now what is the step number 2? Right minus left and up minus down. You have to copy this screen under the title of x right minus left. Remember, calculator should be calculator should be in degree mode.
Sir, for the x, is it 0.07?
Okay, and what about y?
1 second, I'm gonna do it. One point zero seven.
1.07. Good. That's a good question. Answer should be written. Presently, you can write 3 significant figure, but once you reach the final answer, as I mentioned in my first class, perhaps that once you reach the final answer, the answer should be having the same number of significant figure as the question. For the time being, it's fine. Now we move to our next step. Step number 3 and 4.
Yes.
Or maybe it's step number 3. Was there any step number 4 there?
4? No.
Okay. Step number 3, magnitude and direction. So if you find the, if you know the X values and Y values, so if you can solve them,
Sir, is the magnitude 10?
I'm getting magnitude as 1.073 after taking under root. And angle I'm getting is 86.2.
Okay. So, sir, what is the X and Y values that you put, sir?
The previous part,
Okay.
0.0711.
Okay.
0.0711.
Yeah, now it's coming from you, 1.07.
Achha, okay. Check the angle also.
Okay.
And both of you can answer me that why I'm saying that it is in first quadrant.
It's because the X and Y are both positive.
Yes. When answer is coming in first quadrant, then that would be the final answer. No further correction is needed. If answer comes, if the angle is coming in first quadrant, then no further step is needed. It would be taken as the final answer. So write under it that if angle theta is in first quadrant, no further step is needed. If angle theta is in first quadrant, no further step is needed. Definitely it means that if angle is not coming in the first quadrant, you have to adjust the angle. So right under it, if angle theta is not in the first quadrant, final answer needs adjustment. This is that adjustment which we gave that first, second, third quadrant. And this is the adjustment which I told you to use theta 180 minus theta 180 plus theta and 360 minus theta. So you have to copy this screen also.
Okay. Done, sir.
Okay, Rima, also let me know once you have copied it. Example number 2. Now you have to copy this screen. You have to copy this example. This is example number 2. This method is challenging and it needs good practice. And as mentioned, we won't be doing much questions in our regular class. We will be doing extra class work for past paper and we will be solving more questions there. And that will be beneficial because we can manage the theory in a speed.
Okay, sir.
You have to copy. Okay, Ariba, have you copied it?
Yes, sir.
Okay, good. Then now proceed with it and resolve all the vectors.
Sir, I have a question.
Yes.
When you're going from right to left, finding the x, this like there's two values on the right hand side.
You have to add them.
Add them, okay. Sure.
the main formula is right minus left and up minus down.
Okay.
So complete this. I'm just coming. Complete this.
Okay.
You need subtraction. See this working? Let me know if you people have solved it. I need the values of X and Y.
So for X, is the value 13.3?
Good. And for Y?
I'm finding it out.
Okay, right, Ariba, 54.603. And what is the value of X you are getting? Sahi. That's good. So we are getting X and Y values. So now move to the next step, the magnitude step, and find the resultant magnitude and theta. And I'm just coming, complete this screen.
Okay, sir. Done, sir.
So angle is matching. Sad, are you having the same answers?
Yes, sir.
And look at the values of X and Y. They both are plus.
X and Y. Yes, sir. They're both with plus. So it's in quadrant one, the resultant force.
They are in the first quadrant. They are in the first quadrant, so we can take it as our final value answer. and no further step is needed for angle step.
Sir, what is the further step that is needed when
If
it's
the
not?
angle, if the quadrant is, because that's not important nowadays, so
Well,
we are not focusing
you
on
do
that.
180. You do the thing that you like wrote.
That 180. Suppose that you are getting x positive and y negative, then you will get the answer and you will simply put 360 minus theta and your answer will change to the next quadrant. That is something which is not common in present papers. It's not coming. But when we do the past paper, then it will be easier to explain it.
Okay, sir.
Now, give this heading unit prefixes.
So are we done with unit 1?
No, the chapter 1 is continued.
Okay.
This is a big chapter. And in the previous year, 1 year back, these are 2 chapters actually. Some bigger chapter now. But unit prefixes is not something very big. It's our O-level memory to connect back. When you want to magnify a quantity, you have some units, kilo, mega, giga, and tera. This is a good memory to put it back. And after giving the heading, copy this screen.
Okay.
These are used for diminishing a quantity, decreasing the size of a quantity, deci, centi, milli, micro, nano, pico. You have to copy this screen.
Okay.
Let me know once you have copied it.
Okay.
Ariba, have you copied it?
Yes.
Okay, good. So we keep it up to here and we will continue this in our next class, inshallah.
Inshallah.
Allah Hafiz. Thank you. Bye.
Sir, thank you.